Hello everyone, welcome to this channel. If you're new here, my name is Hasan. Let's begin our 14th part of the video series. But before that, as you can see, the surrounding has changed a little bit. The setup is a little bit different. In order to spice it up, I have set up this thing in this way. I hope you love these lighting conditions, okay? So let's begin our 14th part of the video series, and today we'll be introducing the concept of lens to you. So it's an easy video. We won't be going through any kind of numericals, but the fundamentals of lens. Okay, we'll be discussing about the different kinds of lens like the concave and the convex lens. Then we will dive into the classification of concave as well as convex lens. There are three kinds of concave and three kinds of convex lens. We'll be looking into that, and then we'll look into some of the terms that are related to lens. So once we understand those terms related to lens, then what we can do, we can understand the concept of lens in a much better way. If you can build a good fundamental, then things after that becomes easy. So let's build our fundamentals today in a stylish way and smash those concepts so that whenever questions are asked from this part, we can smash those in exam. So let's begin. But before that, let's roll the intro. Okay, now let's start our study on the concept of lens. Let's start with our definition. A lens is a transparent refracting medium bounded by two surfaces, one of which must be spherical. A very straightforward definition. Now, it has to be transparent because if the medium is not transparent, then there will be no refraction, and there should be two bound surfaces, one of which should be spherical. That's the condition. Okay, why one of the sides should be spherical? Because as we move forward and we define different kinds of lenses, we'll see that there are certain kind of lenses in which one of the side is plane and other side is a spherical surface. This kind of lenses do exist, and there are two kinds of such lens. One is plano-convex, another is plano-concave. So don't worry, I'll be explaining which one is plano-convex, which one is plano-concave, but you need to understand the definition that it is a transparent refracting medium bounded by two surfaces, one of which must be spherical. That is, both of the surface may or may not be spherical, but at least one should be spherical. Okay, this is clear? This is all about the definition of lens. Now let's move forward and see the different types of lenses that exist. Okay. So if you look into the types of lenses, then lenses can be classified mainly into two parts, that is convex lens and concave lens. Let's look into convex lens first and see. As you can see in the figure, the edges are thin and the center is thick for convex lens. So I have written it down for you that it is thin at the edges and number two is thick at the center. So these are the physical property of convex lens. So let's see, if this is a convex lens, okay, then this lens is known as converging lens, because if parallel rays comes and hit this lens, then after refraction the rays converge towards a point. Therefore these lenses are known as converging lens. So simply you need to remember that convex lens is also known as converging lens, and this can be asked in objective. Now let's move on to our second type, that is concave lens. If you look into the physical structure of concave lens, then you will see that it is just the opposite of convex lens, that is thick at the edges and thin at the center. So you can see it is thick at the edges and thin at the center, just the opposite of convex lens. But these lenses are known as diverging lens. Here it was known as converging lens, but this is known as diverging lens. Why? Because if suppose this is a concave lens, then if similarly we will prove that if parallel rays comes and hit this concave lens, then after refraction what will happen, it will diverge. Okay, after refraction it will diverge, the rays will diverge. Since the rays are diverging, therefore these kind of lenses are known as diverging lens. So simple as that. So concave lens is known as diverging lens and convex lens is known as converging lens. Very simple. Now I have explained how to remember which lens is which. Like in the mirror, there are also concave mirror and convex mirror, and I said that the reflecting surface, if the reflecting surface is this one, like a cave, you can see the reflecting surface is the cave, therefore it is a concave mirror. Similarly, if the refracting surface is in the shape of a cave, then we can say that this is a concave mirror. If you can remember this is a concave mirror or a diverging lens, then we can easily say that the opposite is a convex lens. Simple as that. Now how to remember which one is converging lens and which one is diverging lens? Very simple. Always remember that we have already learned prism, isn't it? Remember that light always after refraction bends towards the base. Okay, bends towards the base of the triangle or prism. Okay, so light always bends towards the base after refraction. Okay, now let's look into this diagram. Now convex lens, if you break this lens into like this is a triangle and this is again a triangle. So you can see the base of the triangle is in this direction, therefore rays will come and bend towards the base. Rays will come and bend towards the base. So convex lens, if you can remember the shape of the lens, then you can divide it into triangle and then find out the bending of the rays, and you can easily say which one is converging and which one is diverging. As you can see that this is converging. Similarly, if you look into this concave lens, then we can draw a triangle like this, isn't it? And we can draw a triangle like this. So these are the base, these are the base. So if light rays comes and hit here, if light rays comes and hit here, then it will turn towards the base and this will turn towards the base. Therefore you can see that the rays are diverging. Therefore concave lenses are also known as diverging lenses. I hope this is clear, simple as that. Now let's move on to our further classification of convex lens and concave lens. As you can see that convex lens can be further divided into three subcategories, that is biconvex lens, plano-convex lens and concavo-convex lens. Very simple, biconvex means both the surfaces are convex. Bi, okay, bi means two, so both the sides are convex lens, so these kind of lens are known as convex lens. So this is a convex lens, and again if you see it from this side, this is a convex lens, so this is known as biconvex lens. Now plano-convex means one of the side will be plane, so we can see this side is plane and this side is convex, so we say that this is a plano-convex lens. And the number 3 is concavo-convex lens. If you look at from this side, then this is a concave lens, and if you look it from this side, then this is a convex surface, okay, convex lens. Therefore you can say that this is a concavo-convex lens. The thing that you need to remember is that these combination of surfaces will ultimately give us converging lens. Okay, that means if we allow rays of light to come and hit here, let me pick another color, let me rub this off. So if light comes and hit here, then after refraction it will bend towards a certain point, because this is a convex lens. Okay, therefore we can say the overall nature of all of these lenses are converging. Similarly we can say that if I rub this off, if light rays comes and hit here, then after refraction this will bend. Why? Because it is a convex lens. We know convex lens is a converging lens. Now the degree of convergence may differ according to the surfaces, but it will ultimately converge, and we know that if the rays of light converge, then that's a convex lens. Now similarly for concavo-convex lens, even though this is a concave lens and this is a convex, okay, but the overall, if we combine these two surfaces, the overall will act as a convex lens. That is, it will act as a converging lens. That means if parallel rays falls here, then it will ultimately converge. Okay, so therefore this is known as convex lens, and the full combination is known as concavo-convex lens. I hope this much is clear. Now let's move on to our next classification, that is classification of concave lens. Now in the similar fashion we can classify concave lens into three parts, that is biconcave lens, plano-concave lens and convexo-concave lens. Now again if you see, it's written that the overall nature of all of these three lenses are diverging. That means after refraction the light will diverge. Since this is a concave lens and this side is a concave lens, both the surfaces are concave, therefore this is known as biconcave lens. Okay, that means if parallel rays comes and hit here, after refraction it will move away or diverge. Okay, therefore this is a concave lens, and since both the surfaces are concave, therefore it is known as biconcave lens. Okay, and this is the most important one. We'll be learning mainly about biconcave and biconvex, and in exam also mostly 90% of the time they will ask you about biconcave and biconvex lens. Okay, now let's move on to our next one, that is plano-concave lens. Here we can see that one of the surface is plane, another surface is a concave, therefore this is known as plano-concave lens, but the combination will produce diverging rays. Okay, therefore this is known as concave lens. Similarly convexo-concave lens, if you look into this, now why it is known as concave lens, because this will ultimately diverge the rays. Okay, after refraction it will diverge, and you can see that for concave lens we have said that the edges should be thick and the center should be thin. Similarly if you look into this figure, then we will see that the edges are thick and the center is thin, therefore this is known as convexo-concave lens. That is, one side is convex, this side is convex, and this side is concave. but since the center is thin and the edges are thick, therefore the ruling is that of a concave lens. That means it will act as a diverging lens. I hope this much is clear. Students confuse here. I've seen students confusing, and they say that, sir, it's both the thing are same, that is concavo-convex and convexo-concave are same thing. No, they may look similar, but if you look into this concavo-convex, why this is acting as a convex lens? The concept is that the edges are thin and the center is thick. Therefore, it is acting as a convex lens, even if one of the side is concave, another is convex. Here also you can see that one of the side is convex, another is concave, but it is acting as a concave lens. Why? Because the edges are thick and the center is thin, therefore it will diverge the rays. I hope this much is clear. This is all about the classification of concave and convex lens. That is, as you can see that all the three kinds of concave lens are actually diverging lens, and all the three kinds of convex lens are converging lens. Okay, this is clear. Now one thing you need to remember is that in exam mostly we will be dealing with thin lenses, or in this chapter we will be dealing with thin lenses. Okay, we won't be dealing with thick lenses because thick lens becomes complicated. So all the question that comes in NEET will be dealing with thin lenses. Okay, so this is all about the classification of concave and convex lenses, or as a whole the classification of lens. Now I'll be looking into some of the terms related to lens. So now let's look into that. Okay, now let's look into the first term, that is center of curvature, and the concept is same as that we have learnt in mirror, but there is a subtle difference or a minor difference between the center of curvature in mirror and the center of curvature in lenses. In mirror we have only one center of curvature, as I've written it down here. In mirror we have only one center of curvature because in mirror there was only one spherical surface, isn't it? This was one of the sphere, so we got only one center of curvature. But here in lens there are two spheres, therefore there will be two center of curvature. As you can see in the figure that this is one of the sphere and this is the second sphere. So the center of the first sphere is C1, this one, and the center for the second sphere is C2, and these two spheres combine to produce a lens. As you can see, it is shaded here. This is actually the lens. Okay, since these lenses are created by two spheres, therefore it have two centers. Okay, unlike mirror. In mirror there is only one center of curvature, but in lens there are two center of curvature. So basically center of curvature is actually the center of the sphere that creates the lens. Okay, I hope this is clear. Now let's move on to our next term, that is radius of curvature. So what is radius of curvature? It's very simple. As you have seen that this is the center of the curvature. Okay, let me pick another color. This is the center of curvature for the second sphere, and this is the center of curvature for the first sphere, basically the center of the sphere, as you have seen earlier. Now what is radius of curvature? Radius of curvature is similar to the thing that we have learnt in mirror, that is, it is the radius of the sphere that creates the lens. So we can see that this is the first sphere, so this one, the radius of the first sphere, is the radius of curvature of this surface. Okay, and for the second sphere, this is the radius of the sphere. Okay, so the radius of curvature for this surface is actually this one, R2, isn't it? Therefore basically you can say the radius of curvature is actually the radius of the sphere that makes up the lens. Okay, but again there is a bit difference when it comes to radius of curvature in lens and radius of curvature in mirror. In mirror we have only one radius of curvature. The reason is simple, because mirror is made up of one sphere, but in case of lens there are two radius of curvature. The reason is again simple, because lens is created by two spherical surfaces. Simple as that. So this is radius of curvature. I'm not writing out the definition because I assume that you know it. I'm assuming that you have gone through my video lecture on the concept of mirror. Okay, and it has been explained, each and every term has been explained, and it is quite similar. So I have written it down there, so I'm not writing it down here. Okay, I'm to wrap up this concept as fast as possible, but making things very clear. Okay, now let's move on to our next term, that is what is principal axis. We'll be looking into that. So what is principal axis? Again, it's a very simple concept. The line joining the two center of curvature of the lens is known as the principal axis. As you can see it in the figure, that we have joined this C1 and C2 by a line, and that line is known as principal axis. It is also sometimes known as optical axis. Okay, so you need to remember this term. So if principal axis is the line joining two centers of the lens, then what will be the principal axis? How to draw the principal axis of plano concave or plano convex? Because we know that for plano convex there are no two centers. or plano-concave, there are no two center, because one of the side or one of the surface is actually a plane surface, and we know that plane surface doesn't have a center. Then how to draw principal axis for plano-convex or plano-concave lens? So let's see that. How to draw that? It's very simple. We know that radius of curvature for plane surface is actually infinity, isn't it? This is a plane surface. I've explained this thing in mirror, that for plane mirror the radius is actually infinity, isn't it? So how to draw the principal axis? Now let's look into this plano-convex mirror. Okay, the principal axis. So how to draw the principal axis? So we need to find out the center first. So for this surface, okay, this is a spherical surface, the center will be somewhat here, okay, C1. But this surface, that is the plane surface, this one doesn't have any center. Therefore what we need to do is that we need to draw a line in such a way that the line is 90 degree to the plane surface. Then this line will be the principal axis. So we cannot draw a line like this and say this is the principal axis, because this will not produce 90 degree. Okay, so the principal axis is this one, that is passing through the center, and for the plane surface it will be 90 degree to it. Then this will be the principal axis. Okay, simple as that. So this is all about the concept of principal axis. Now let's move on and look into our next term, that is optical center. So what is optical center? Again, it is a point on principal axis of lens through which light passes undeviated. As you can see, this is the optical center. So if light passes through that point, then it will go undeviated. And the assumption is that that lens should be thin, because if the lens is not thin, then this won't be the optical center, because if the lens is not thin, then the rays will not pass undeviated. So in your syllabus you need to understand optical center only for thin lenses. Okay, so again I will tell you that optical center is a point on the principal axis through which light passes undeviated. Simple as that. So I've shown it for convex lens. Now for concave lens it is similar. So if this is our concave lens and this is our principal axis, then this will be the optical center somewhere here for thin lens. Then so if rays goes through this point, then it will go undeviated. Okay, so that point is known as optical center of the lens. Okay, simple as that. This is all about optical center, but the assumption is that the lens should be thin. Okay, this is the assumption, because if the lenses are not thin, then things becomes complicated. Okay, for optical center I won't be discussing that. Now let's move on to our next term, that is focus or focal point. So what is focus or focal point? Let's understand this thing. We have understood this concept in mirror, so it's a bit different here. We know that in mirror there was only one focus. Okay, here there will be two focus because there are two spherical surfaces. In mirror there was single surface, therefore there was only one focus. But it's not that tough, it's easy. Let's look into that. So let's see what is first focus for convex lens. The first focus of convex lens is a point such that if rays of light comes from that point, then after refraction through the lens, the rays becomes parallel to the principal axis. This is the first focus. Okay, I'll repeat again. It is a point from where if light rays comes and hit the lens, then after refraction those rays will become parallel to the principal axis. That is the first focus of convex lens. Now what is the first focus for concave lens? If you look into this, then it's simple. If light rays moving towards a fixed point such that after refraction it becomes parallel to the principal axis, then that point is known as first focus of concave lens. I'll repeat again. When rays of light moving towards a point such that after refraction the rays becomes parallel to the principal axis, then that point is known as the first focus. Okay, first focus for convex lens or concave lens is not that important. You don't need to remember. I just explained the thing. Okay, the most important part is the second focus, and mostly in your exam or numerical we require the second focus to solve numericals. Okay, so first focus is only for your concept because it's there in your syllabus, so you need to know. That's why I've explained the thing, but the second focus is much more important. Okay, let's look into that. Now second focus is also known as principal focus because that's the most important one. Now let's look into that. So please pay a little bit more attention here. Second focus for convex lens. Always remember one thing, for finding second focus we will use always parallel rays. Okay, in the earlier case we haven't used parallel case in both the scenario, like for convex lens and concave lens, but for finding second focus we will be using always parallel rays to find that point. Okay, I hope this much is clear. Therefore let's look into this convex lens first. So if a parallel rays of light that is parallel to principal axis comes and hit the lens, then after refraction it will converge to a fixed point. That point is known as focus or the second focus or the principal focus of convex lens. So I'll repeat again, when parallel rays of light that is parallel to principal axis comes and hit the lens, then after refraction it converges to a fixed point. That point is known as second focus of the lens or the principal focus of the lens. Okay, now let's look into the second focus for concave lens. It's simple again. Since we're finding the second focus, we'll be using parallel rays again. So let's see, if parallel rays that is parallel to principal axis comes and hit the concave lens, then after refraction the rays will converge, as you can see. Now if we extend these diverging rays backward, then we will see that those rays will meet at a point, and that point is known as second focus or principal focus of concave lens. Okay, simple as that. So when rays of light parallel to principal axis after refraction diverges such that the rays appears to come from a certain point, then that point is known as second focus or principal focus of the concave lens. If you just remember the ray diagram, then it's very easy. Okay, now let's understand what is focal length. If you have gone through the mirror video, then this is just piece of cake. The distance between optical center and focus is known as focal length. Okay, now I have told you that the second focus is basically the principal focus of the lens. So, and all the numerical problem will be solving using second focus. Now let's understand the sign convention for second focus. The focal length for convex lens, we take it as positive. Why? The sign convention is similar to that of mirror. We know that the direction of incidence is always taken as positive. Now look into this diagram. The direction of incident ray is this side, so this side is taken as positive. And if you look into the focal length, the direction of focal length, we always measure length from the optical center. Therefore, in order to measure this focal length, we need to move from optical center towards the focus. Therefore, we need to move in this direction, which is similar to the direction of incident ray. Therefore, it is taken as positive. I hope this much is clear. If you haven't understood the sign convention, then I'll request you to check the sign convention video on mirror. Okay, now the focal length for concave lens is always negative. Now again, the concept is similar. The direction of the incident ray is this one for this diagram. Okay, so this direction will be taken as positive, but the focal length, we know the measurement is always done from the optical center. Therefore, the distance that we will measure is from the optical center towards the focus, which is in the opposite direction to the direction of incident ray. Therefore, this will be taken as negative. Simple as that. Using this concept of second focus, we basically say that the focal length of convex lens is always positive and the focal length of concave lens is always negative. Okay, but if in the question they ask you a tricky question in order to trap you, they can ask you like, what is the sign of the first focus of a convex lens? What is the sign of focal length of the first focus of a convex lens? Now if you look into this, then we know the direction of incident ray is this side. Okay, but the measurement of focal length is done from the optical center, and in order to measure the focal length we need to move in this direction from the optical center. Therefore, it is negative. I hope this is clear. So the focal length of the first focus of a convex lens is always negative. But they will never ask in numerical, we will be using only the second focus. But if the question is tricky, you need to check whether it is first focus or not. If it is not mentioned first focus, then you need to consider only the principal focus, that is the second focus. Therefore, we know that for second focus, the focal length of convex lens is always taken as positive and the focal length of concave lens is always taken as negative. This is the thing you need to remember. Okay, this is the most important part. Now let's understand what is focal plane. This is the last thing that I need to explain, and this thing has been explained in the mirror video also. Now focal plane, we all know that if a ray of light is parallel to principal axis, then after refraction it will meet at a point, and that point is known as focus. Okay, this is for convex lens. Similarly, if the rays are parallel but are not parallel to principal axis, then what will happen? So this is parallel rays, these two rays are parallel rays but are not parallel to principal axis. So after refraction they will converge to a point which actually lies in the same plane as that of the focus. Okay, so that plane is known as focal plane. Okay, the same thing happens for concave lens also. Okay, if this is a concave lens, we know that second focus is, we need to take a parallel rays. Then after refraction these will diverge. Very good. And then if we extend these rays backward, then we will get a point, and that point is known as the principal focus or the second focus of the concave lens. Simple as that. Now if the rays are like this, if I take another color and draw two rays like this, okay, then what will happen? Then after refraction it will diverge like this, and this will diverge like this. Okay, and if we extend this back, then these two rays will meet at a point in such a way that these 2 points lie on the plane, same plane, and this plane is known as the focal plane. I hope this much is clear. Simple as that. So this is all about the terms that are important for lens and that you need to understand. If you understood these terms, then you're good to go. So this is all for this video. This is just the introduction of lenses. In the next video, we'll be looking into the image formation in lenses. Okay, so this is all for this video. If you enjoyed this video, then please give it a thumbs up, and if you haven't subscribed to this channel, then please consider doing so. Till next time, enjoy your studies and build your concept, and I will catch you all in my next video. Bye bye.